Hello, guys. Welcome to today's class. The name is Akim. As always, names never change. Hmm. Mm-hmm. That's some coffee there. All right. So today we're going to be talking about introduction to programming thinking. So as a programmer, there is a way that you structure your mind in order to think through programs. Imagine a system as big as Google or WhatsApp. So to build that kind of a system, you have to be thinking in a certain type of way. So before we dive into the actual code, I would like to show you how a programmer thinks. How do we think about the programs that we want to create? Okay, so I have a PowerPoint here in Vim. I hope today will be the first time that you get to see a PowerPoint in Vim. All right, but this is my PowerPoint. Let me go to Vim Pseudocode. All right, so here is today's class. I hope you follow through. So, as I've already said, we are talking about introduction to programming thinking. All right, so as a programmer, there is a way that you think, the program that you're going to build. So, first of all, you have to understand that there are certain constructs that are common to most programming languages. Okay, and these constructs are like variables. In every programming language, you're going to find variables. And those variables have data types. Okay, so as we go, I'll be expounding more on these concepts. But before we go into the today's topic, I want you to understand that we have constructs in a programming language. So as I was saying, we have variables in a programming language. So the variables are what stores our data. For instance, numbers, text, and what have you. So these variables can have data types. We have integers, we have floating types, we have chars, we have strings and booleans. Okay, and we will get to understand the data types that are there available in Python. Another construct that we have is operators. So these may be arithmetic or relational. So the arithmetic operators are the ones that help us to make mathematical calculations in our program. For instance, adding two numbers, we can use the addition operator. So we have relational operators that help us to compare things. For instance, less than, greater than, less than or equal to, greater than or equal to, not equal to, and is equal to. And we also have logical operators for logical operations. In a programming language, we also have what we call control structures. Okay, so when dealing with control structures, we talk of conditional statements. For instance, it may reach a point where you want to make a condition in a program, like if A is equal to B, do this and that. So that is a conditional statement. And we also have what we call repetition structures or loops. So these are the keywords or the things that help us to do an action repetitively. Okay, so we have the for loop, we have the while, and we have the do while. So they control the flow of execution based on conditions that we have given them. So as we have seen these constructs of a programming language, there is a simpler way of representing them in a piece of paper in simpler terms before you start the actual coding. Mind you, we are starting with small programs, but there comes a time where you have to build big and bigger programs. So for you to come up with a very big program sometimes, and usually most of the times, you break down that program in simpler concepts, in simpler algorithms. So the way we represent these things in simpler simplified English, simplified terminologies and words is what we call a pseudocode. So by definition, according to the Oxford Dictionary, a pseudocode is a notation resembling a simplified programming language used in a program design. Okay? So it is just a resemblance of an actual program. You cannot write a pseudocode and compile it or run it on a computer. No. It is just there to aid in communication or to simplify your idea on paper that this is the program I want to build. And the program should have this and that and those conditions, these steps, these function calls, and what have you. So as a programmer, you are supposed to think and imagine about your programs. This is the way you're supposed to think and imagine your programs. So you think in the pseudocode way. You see the examples that are following. I remember back then at the University of Livingstonia, our lecturer back then who was teaching us programming in C, Mr. John Memory Banda, he told us that our heads must become a living compiler. So as you're working, you're compiling programs and you're checking the output. Okay? So because we are doing Python here, I will tell you today that your head must become a living interpreter. So you must be able to think about the program, visualize the program, check the output in your mind. Okay? But the way you do it on paper is by using what we call a pseudocode. So a simplified notation that resembles a program. All right? So here we have examples of pseudocodes. For instance, we have given you an assignment or you have a task to write a program that finds the largest number between three numbers. So those numbers might be in arrays or they might be just numbers that have been given. Okay, so you see that in the pseudocode, this is not Python code. This is the pseudocode we are talking about. So in the pseudocode, I will design my program like this. I'll say start. Okay. So start is one of the keywords that are there in pseudocode. You can write your pseudocode in any style that you may want, but there are common terminologies or common ways that we use to write a pseudocode. So one of the things we do is writing the keyword start. So start signifies the start of a program. Okay, and we also have a keyword here end, which signifies or shows that we are ending or terminating the program or function as it may be. So you also see the keyword input here, which shows that we are requesting for an input from the user, which may be anyone using the program. And we have the if there. Remember we talked about control structures and conditionals. So we have the if there and we have the comparison operator greater than and the logical operator there. Okay, so you will see the keywords that we talked about on top here about the constructs of a programming language. You see the elements of a programming language, the most common elements, you'll be seeing them in the pseudocode. Okay, so let us see what our program is asking us to do. So we are saying that we are writing a program to find the largest number between three numbers. So we are saying we are going to start the program. So that's the first keyword, start. So once we start the program, we are going to ask the user input three numbers, which may be input number 1, number 2, number 3. Okay, so we've gotten the numbers. Now, how do we check which one is greater or which one is smaller? So now comes the conditions. We are saying if number 1 is greater than number 2 and number 1 is greater than number 3, then we are going to display that number 1 is the largest number. So this is just in simpler terms. There is no code that we have written yet. We are just designing our solution. We are just designing our program. We are thinking about the program in the programming way. So we are saying if, else if number 2 is greater than number 3, then display that number 2 is the largest, or else display number 3 is the largest. So end the program. So right here we have seen that we have ended our program. Okay. So another thing that we have to understand is how a program is executed in a computer. So a program is executed sequentially. The moment we run our Python code, the computer goes step by step, line by line, checking each and every piece of line of code, executing those instructions that you have given it. Okay? So if you say input 3 numbers, it is going to do just that. So it's not going to execute here and then we jump to the end and then no, it goes sequentially, step by step, unless you have called a function. So a function might cause the flow of execution to jump from one line to the next. But if you go deeper, you understand that a function is still, when we are executing a function, is still a sequential flow of execution of executing a program. Okay, so let's continue. We have the second task there. We are requested to calculate the average of 5 numbers. Okay, so as always, we are going to say start. We are starting our program. So instead of doing the assignment as we could have done it in an actual program, we are going to say set total to 0. So that's our total. So the control flow of repetition, this is how we are going to do it in a pseudocode. We are going to say repeat 5 times. So for 5 times, we are going to ask for a number from the user. So prompt user for the number. So once we get that number, we are going to add that number to the total that we are having. So for the first iteration of this repetition, we are going to add the number to the total 0. So we are going to do that 5 times. So here we are setting average to the total amount that we have calculated divided by 5. Then finally, we are going to display the average of the number that we have gotten. So as you can see, each and every program here is going in very simple terms that even a layman can understand what a program is doing without even knowing how to write, just by simply studying the pseudocode, checking the English. They are going to know exactly what you as a programmer had intended for to do. So the final example is this one. We are checking if the number is odd or it's even. So as always, we are going to start our program. Then next, we are going to prompt the user to enter a number. If the number modulus 2 equals 0, then we are going to display that the number is even. I hope you know modulus, what it means. Those of you who have done mathematics, when we say 4 modulus 2, we are saying we are trying to calculate the remainder when 4 is divided by 2. So when 4 is divided by 2 and the remainder is 0, we know that the number is even. But if we say 5 modulus 2, we know that right there the remainder is 1. So that means the number is an odd number. So this is the program. We are saying if number modulus 2 equals 0, then display the number is even. Else, display that the number is odd. So that is it about the pseudocode. So in the next video, we are going to now start getting to understand some of these constructs of a programming language. And after we get to a certain point, we are going to write programs based on these pseudocodes. Okay, you can write them, you can attempt to write them at your own time, but we can come up with Python code from these pseudocodes that we have generated here. So thank you for watching this video. I hope you get to understand about the pseudocode. If you don't fully comprehend them, please you can type in the comment section asking for clarity where you've not understood. And as always, like this video, share it with your friends, and subscribe. See you in the next video. Okay, let's quit. Exit.